We look into the third aspect, the ceramic fritting. The advantage of ceramic frit is predominantly for a design aspect where you don't have a simple glass facade, and it brings in the architect's creativity in bringing out designs, different kinds of designs, and makes the building very unique. Along with this design, it also has an implication in terms of energy factors and also visual discomfort, which we would be discussing now. If you see the ceramic frit technology, the basic form of ceramic frit technology is the silk screen ceramic fritting. What you see here at the bottom is the glass, and the blue line with small pores indicates silk screen. The material is made of silk with very micro porous openings, and what we do is the black that you see is the ceramic ink, which gets squeezed over the silk screen, and wherever you have these the microporous pores, it gets transformed onto the glass, and corresponding designs or shapes is being formed. The second type of ceramic frit technology that is available is in terms of roller coating, where you have deposit a uniform layer of coating by use of rollers, single roller which is rotating in same direction or opposite direction, and you see the red which is the ceramic coating that gets deposited onto the surface of the glass. The third type of ceramic frit technology that is available is called as digital printing. This is very similar to printing of our photographs, where you print it on a paper. In this case, you print it on glass. So it gives you a complete flexibility in terms of multicolors, which I will be talking in my next slide. So these frits are specific chemicals or minerals which has some kind of colorants, and also are suspended in pine oil, and they are printed onto the surface of, which is commonly used for tiles. It is also used for glass and also metals. What happens once you apply ceramic frit onto the surface of the glass, it is mandatory that we temper the glass. So what happens is this: the pine oil burns off, leaving these frits, which is grounded glass, to be fused along with the glass. So once you do a ceramic frit onto the surface of the glass, and once it goes inside the tempering, the design that we do onto the glass becomes part of glass, and it never comes out. So each of the technology has its own advantage and it has its own limitation in terms of application. So that's why we have different types based on usage and based on application. So the silk screen, which is commonly used, it gives you a complete flexibility in terms of creating multiple geometry images and also in terms of patterns. The most commonly used in terms of are in terms of polka dots, where you have various coverages, or some kind of lines or patterns are commonly used for silk screen ceramic fritting. The second type, the roller, it's generally one layer of coating that you do, and it is a uniform color with 100% coverage. But what is the benefit that you get is in terms of the appearance is very high when compared to ceramic frit. Generally it is very high because the thickness of the coating is very high, so which brings in the glossy effect and the metallic shade. For example, here you can see several shades of yellow, green and gray. So you can get that glossiness or the superior finish in terms of roller coatings. Digital printings are predominantly used in terms of glasses, where you have multiple colors. You have more than 3 or 4 colors onto the same glass, or if you want it could be as complex as printing someone's face onto the glass. So for complex colors which involves more than 3 or 4 colors in the same panel, generally digital printing is a preferred technology. As you move from silk screen to roller to digital, it gives you in terms of the color, in terms of glossiness, but it also has an effect in terms of the costing which keeps increasing. So based on what is the requirement, a suitable technology can be adopted. So the primary purpose of doing a ceramic frit is to bring into design to the facade. But by doing the ceramic frit, it also helps you to optimize in terms of light transmission and also solar insulation. Here what you see a graph. At the x-axis is the frit coverage. This I have considered for a clear glass, and the percentage here represents what is the percentage. The blue line represents light transmission, and the red line indicates the solar insulation, which is 1 minus solar factor. So for example, 0% when I don't do any kind of ceramic frit, and this is for a clear glass, you can see that the light transmission is very high, 89%, and solar insulation, it insulates only 15% of heat. Rest of 85% of heat is allowed inside. So which means that very high amount of heat is passing through. So as you see that when I move from 0 to 100, the solar insulation keeps increasing, which means that when I do complete 100% coverage of ceramic frit, I am providing 60% insulation and only 40% of heat is allowed inside in comparison to 0%, which allows more than 85% of heat. So this gives you doing ceramic frit or designs onto the glass also has an energy implication where you can optimize in terms of light transmission and also in terms of heat gain. This can be strategically designed in terms of reducing visual discomfort. For example, the vision panels can have specific kinds of designs on top of the glass which will reduce the direct light, which creates visual discomfort. At the meantime, it can also reduce the amount of heat gain, so the cooling energy is reduced. Here is one typical example which I have showed. So the glass, what you see on top is the same building where you have you look at from outside, so you see a typical pattern or design onto the building, which makes the building unique in terms of its design. And from inside, based on the coverage at the periphery where you can see through, has typically about 40 to 50% coverage, and the dense area that you see at the center varies between 50 to 80%. And based on the coverage and based on patterns in terms of spacing between two patterns, the transparency or the see-through effect can be still maintained, making some kind of unique designs onto the glass facade. So this is one typical application. What I present to you is some of the innovative designs which has used ceramic frit technology in terms of onto the building facade, which make it unique in terms of appearance. So one interesting factor here is, though the design looks very complex, all of these was done using the silk screen, which is having a screen and you squeeze it to create a design. So it gives you a complete flexibility for an architect to create any kind of designs onto the facade, and which also provides in turn the energy benefits with respect to reducing the heat gain and also reducing or optimizing the visual comfort and eliminating the visual glare. And interestingly, here you see a building which is at the left bottom, where the currency money was printed onto the facade. So it gives you infinite possibilities in terms of the design that you would like to bring into the building. So what we have seen so far, the facades which could possibly define the future in terms of coating technology, which is where the technology or the glass performance is going towards super selectivity, where the light transmission is not hampered and you gradually bring down the heat gain in terms of using super selective coatings with double silvered and triple silvered. What we foresee this as a future is in terms of active systems, which change its performance based on environment condition, and ceramic fretting, which makes building unique, which makes building designs very unique, and also bring about energy efficiency and also daylight comfort. Thank you. If you have any questions, I can take them.
Thank you, sir. Ladies and gentlemen, we will now begin the question and answer session. If you have a question, please press *1 on your telephone keypad and wait for your turn to ask the question. If you would like to withdraw your request, you may do so by pressing *1 again.
Okay, I have few questions that has come through chat. So there's a question from Mega. Elaborate pyrolytic solar control glasses.